Hi there. This video is an exam paper walkthrough of the AQA GCSE Mathematics Foundation Tier Paper 3 from summer 2023. This paper is worth 80 marks in total, and this is the third video of 4. It will focus on questions 13 to 18, which account for 17 of these marks. AQA Paper 3s are calculator papers, so a calculator should be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 13. Here are 3 straight lines. So we've got AB, CD, and then we've got that line, that intersecting line there. Are the lines AB and CD parallel? So we want to know if these two lines are parallel. So to figure this out, we need to know some of the other angles, because there are some rules that can tell us that lines are parallel. So corresponding angles need to be equal, alternate angles need to be equal, co-interior angles need to sum to 180 degrees. So if we fill in as many angles as we can see if one of those rules applies. So the first angle I'm going to complete is this one. Vertically opposite angles are equal, so this angle must be 105. If this angle is 105, then I can find this one by subtracting 105 from 180 because they're on a straight line. So 180 subtract 105 is 75. Okay, I can also find this angle using the same rule. These two angles are joined on a straight line, so they must add to 180. So 180 subtract 95 is 85. Now I'm going to stop there because I've got two angles that I can compare. So you might have been told to look for an F shape. So these are corresponding angles. So if AB and CD were parallel, this angle and this angle would be the same. They're not the same. So we're going to say no, they're not parallel. And working to support your answer, well, you've popped up the angles there, but you could be safe and mention there are no corresponding angles, and that's a condition for two lines being parallel. Question 14. Match the algebra to the correct description. One has been done for you. So these are the algebra statements, and here are the descriptions. So 5D add 7E has been matched to an expression. So this is an expression, not an equation, okay? An equation would have an equal sign, which will make life a little bit easier for us when matching the equation word up, because it means it's going to go not here, because that's not an equal sign, that's an identical to sign. This one is an equal sign, so that is an equation, so let's match that up straight away. Now we just mentioned that 3 lines here, so 2 lines is equal to, 3 lines is identical to. If you have those 3 lines, it means it's an identity, and what that's saying is 2C plus C is the same as 3C. Well, it is, because 2C plus 1C is 3C. So we're going to match that to the identity. Now it's the last one. Is it a formula or an inequality? Well, we're using a greater than symbol. If we use any of the less than, greater than, less than or equal to, greater than or equal to symbols, it is an inequality. So we didn't need to use the formula box for this question. Question 15. Popcorn is sold in bags. 8 small bags have a total mass of 496 grams. 5 small bags and 2 large bags have a total mass of 638 grams. Work out the mass of a large bag. Okay, so I've been given some information about small bags. So I'm going to use a proportion table, which I've used before in previous videos. So this is mass and then number of bags. So 8 bags have a mass of 496 grams. If I want to find out what one small bag weighs, I'm going to divide by 8, and then I can do the same on the other side. So 496 divided by 8 is 62 grams. So one small bag weighs 62 grams. So we're told that 5 small bags and 2 large bags have a total mass of 638 grams. So now I want to know how much 5 small bags weighs. So now I know what one small bag weighs. If I multiply that 5, it will tell me what 5 small bags weigh. So the weight of one bag, 62, multiplied by 5. So 5 small bags weigh 310 grams. So 5 small bags, 310 grams, plus 2 large bags must equal 638 grams. So if I take away the 310 grams for the small bags from 638, it'll tell me what 2 large bags weigh. So 638 subtract 310. It's 328 grams. So that's the price of the weight of 2 large, sorry. So again, bags, mass. This is for the large ones. So 2 bags is 328 grams. So if I want one bag, I'm simply going to divide by 2 and half that. So 328 divided by 2 tells me that one bag weighs 164 grams, and that's our answer. Question 16. The rectangle and the triangle have the same area. So we've got a triangle, and to work out the area of a triangle, it would be base times height and then divide by 2. And then we've got a rectangle, and to work out the area of the rectangle, it would be the length times the width. But here we don't know the length. It wants us to work out the length of the rectangle. So if they have the same area, the first thing I'm going to do is I'm going to find the area of the triangle, because I have the base and height, I can do that. So it's the base of 12 multiplied by the height, which is 16, and then divide by 2. So 12 times 16 divided by 2 is 96 centimetres squared. So the area of the triangle is 96 centimetres squared. The rectangle and the triangle have the same area. So now if I divide that area by the width of the rectangle, it will tell me what the length of the rectangle is. So 96 divided by 7.5 is 12.8. So the length of the rectangle is 12.8 centimetres. Question 17. Match the name to the correct sequence. One has been done for you. So a quadratic sequence has been matched up to this sequence here. So this must be a quadratic sequence. We now need to find a linear sequence and a Fibonacci type sequence. So a linear sequence is one where it goes up or down by the same value between each term. So we're either adding the same value to get the next term, or we're subtracting the same value. So let's try and find that one first. So 4 to 5 is 1, 5 to 9 is 4. Straight away these are different, so that can't be my linear sequence. Let's try this next one. Minus 3 to 1, we would add 4. 1 to 5, add 4. 5 to 9, add 4. 9 to 13, add 4. 4 every time. That's a linear sequence. Now we need to identify the Fibonacci type sequence. So a Fibonacci sequence is a sequence that's generated by adding the previous 2 terms. So if the first 2 terms were 1, the third term would be 1 plus 1, which is 2. The fourth term would be 1 plus 2, which is 3. The fifth term would be 2 plus 3, which is 5. So let's see if we can find that property in a sequence anywhere. So let's continue this one. From 4 to 5, 4 plus 5 is 9. That works. 5 plus 9 is 14. That works. 9 plus 14 is 23. That works. So this is our Fibonacci sequence because we're adding the previous 2 terms to make the next one. Question 18. The number of hedgehogs in England is expected to reduce by 4% each year. So that reduce by 4% is important. Assume there are now 1 million hedgehogs in England. Work out the expected number of hedgehogs in England after 5 years. You must show you're working out. Okay, so if we're reducing by 4% each year, 100% subtract 4 would be 96%. 96% as a multiplier is 0.96. So this is what we're going to use in our calculation to reduce by 4% each year. Now it wants the expected number of hedgehogs after 5 years. So we're going to use a formula that you may have seen as a compound interest formula, but it could also be used for depreciation problems. So when they're being reduced, a repeated reduction over a period of time. So we're going to take that starting number of hedgehogs, 1 million. We're going to multiply it by our multiplier for that 4% reduction, and then we're going to raise it to the power of 5 years. And then we're going to pop that in our calculator. So 1 million times 0.96 to the power of 5. So that tells us, gives us an answer of 815,372.6976. We can't have 0.6976 of a hedgehog, so we're going to write our answer as 815,372.